All right, we're going to do more with parallel lines. We're on the last section of this. No, actually, that's not true. The last section of this day, but not the last section of this chapter. Pardon me?
I thought you said test was after this.
Test is next week. We have one more week.
Oh, I thought you said it was this
It's a quiz. I apologize if you thought that's what I'm doing. All right, we're going to do a construction first. We're going to construct a parallel line. You're going to do that in your homework. And you have handouts with the instructions on it, so you can look at those as we do it. I'm going to actually pause this. You guys need to know something, that on these videos, when they're on my blog, right under the videos, I find people who have done these constructions so you can watch them if you don't know how to do them, okay? Okay, here we go. We have two new theorems. They're the last ones. I put them up here. I want you to notice there are no names for them. So whenever you use them in your proof, you have to state the whole thing. There isn't like the corresponding angles theorem or the converse to the corresponding, and it's actually postulate, by the way. Corresponding angles postulate.
You've got a name. If two lines are parallel to the same line, then they are parallel to each other?
You have to write the whole thing out. That's correct. I'm going to show you what that means. Let's draw some pictures. If two lines are parallel to the same line, okay? So let's show this here. The first one. I have a line here, and I'm going to draw right on top. These are parallel. I'm going to mark them parallel. Okay? Then I have a third line. Come along here.
Oh.
And
Okay, never mind.
this line is now parallel to the first one over here. So let's label them A, B, C. I'm going to tell you that A is parallel to B. Then I'm going to tell you that A is parallel to C. Because of this theorem right here, it says if two lines are parallel to the same line, notice A is in both of them, then they are parallel to each other. So what lines are parallel to each other based on my statement?
B and C.
This is similar to the transitive property of congruence or equality. This is similar to so this is like the transitive property of parallel, okay? So, you want to call it that? I don't know. So, I think transitive implies that we have to have equality. And lines are not equality, they're just parallel, okay? Because if we said equal, we'd be maybe inferring their lengths. All right.
Technically, since it's a line, they are.
Yes, yes. If segments also, we could have, some segments can be parallel but not equal in length. You know what I'm saying? All right. So then I could write that B is parallel, B is parallel to C based on this, number 15. Okay. Let's clear my screen. If you need, I suggest that you write some kind of pictures next to your theorems when you put them in your postulate books. Personally, instead of, when I go through my postulate book, when I used one on tests, if I was looking for pictures, I could go way faster than if I have to read every single word that's on that. Okay. I also memorized where they were on the page, but that's just my personality. All right, and the last one. In a plane, two lines are perpendicular to the same line. If two lines are perpendicular to the same line, then they're parallel to each other. So let's look at this. So I have a line, and it's perpendicular to this one. I'm going to label them again, A and B. Okay. If I make another line, let's call it C. I'm going to make a different color. C. And it's perpendicular to B also. What does it say? It says that in a plane, if two lines are perpendicular to the same line, A is perpendicular to B and C is perpendicular to B. What does it say about these two lines A and C? They're parallel. What kind of angles are these? They're both 90, and a 90 is equal to 90, correct? And what kind of angles are those?
Right.
They're right, but based on the things we were doing a little bit ago on your little red notes, they're not adjacent.
Oh, same side.
They're corresponding angles. Remember when corresponding angles were equal? They're also, if it's 90, you know that this is 90 over here, correct? And those are same side interior. And same side interior have to be supplementary. So we have all of it. So if in a plane, if two lines are perpendicular to the same line, then they're parallel to each other. That was what you were asking me a little bit ago.
Yeah.
And you thought that this line, this word should be changed from parallel to perpendicular, but no, it's parallel.
Yeah.
Okay. All right. These are two more theorems to prove that lines are parallel. Two more. Okay. All right. So now we're going to add a little bit degree of difficulty by adding a couple extra parallel lines in here. I'm doing some examples. This is numbers 6 and 9, and I've given you the answer. Let's pretend I didn't. Right there.
Where's the answer?
Not on yours, on the screen up here. I just erased it. By coloring it white, I think that's the coolest thing. All right. So I'm going to pick green. I haven't done green yet.
Where's the other arrow?
I accidentally deleted it when I colored it in white. All right, so if if I undo, see it's there. Now I'm taking it away. Don't. All right. So now we have 3 lines that are parallel to each other. We need to decide what kind of angles are those. So I have to do some mind work. I know that this angle and this angle are corresponding, correct?
Yes.
And then how does that one relate to the highlighted yellow one? How does the 13x relate to the yellow one that I just made? It's what kind?
Excuse me, sorry. Wouldn't they be congruent?
Because they're corresponding, okay? They are. And I kind of had to, figure, now I have 3 parallel lines. You don't have to give reasons for these. They're supposed to be equal, correct? So then we can write an equation. 3x equals 130.
Wait, 3x.
Is that correct? Did I write that wrong?
13.
Oh, thank you. 13x equals 130. We're going to divide both sides by 13. X equals,
10.
I heard 10. Yes. And then, Amy, then we can come back here and give you back your 10. Okay? When I make these worksheets, they put the answers there, and sometimes when I'm copying and pasting them to put them in my PowerPoint, I accidentally forget to take the answers out. This has only happened that once.
Well, that's okay.
That's all right. No problem.
You can just leave the answer.
What you could do sometimes also, if you're able to do this in your mind, if you're able to erase in your mind, erase like that one and that one so that you only have 2 in your head. I cannot do that.
Really?
I don't have the ability to ignore. I have to use reason to do that. So what I did is I just colored over it white. So I have to do this. I have to say,
You don't have the ability to ignore?
maybe some people, but not lines on paper. All right. I've got this angle goes with this one because they're corresponding, right? And these two are alternate interior. And so this one's equal to that one, and that one's equal to that one. So by the transitive property of equality, they're equal. Was that more complicated for you?
Those are alternate interior.
They are alternate interior. When I went like this,
Sorry, I didn't hear anything.
and when I went like this and like that,
Yeah, that.
I was
makes
able
so
to
much
look
more
better
sense for me.
that is alternate interior. Okay? If you cannot erase like that, I had to do this. I had to say that's congruent to that by corresponding, and those two are alternate interior. All those are equal. Okay? So I can make an equation. 11x plus 6 equals 10x plus 13. Do you have a question, Brett?
No.
Okay, good. Because I would be willing to answer it. We're now they're just getting a little more difficult by adding extra lines in there, and you have to use some more reasoning skills.
You can't just not see those lines.
I cannot not see those lines.
What?
She was asking me, you really can't just take them out? That's actually a gift.
Yeah, I have the opposite problem. I just accidentally skip over things and don't see them when they're supposed to be there. Wait, 10x? Wait, never mind. I saw the 7. I'm sorry. I was thinking you were saying.
Wait, what?
Yeah.
That's what I have.
7.
No, I thought you said something else. Never mind.
Yeah, I thought she got a 10 for the 6. That's 13 minus 6, and I was got to go, wait, what?
Well, yeah.
Eventually, hopefully you guys can try to do this. I'm going to come back a little bit. When you guys are solving equations, I have been going the long route. But if you want to, at this point, those cancel out. If you want to subtract the 10x at the same time and have that all in one step, so this is the 7 here and this is the x there.
I just write the
That is so acceptable.
Go to the x equals.
I was doing it the other way so you could see every one of them because I'm the teacher and I need to make sure you have gotten all of it, okay, Amy?
Can I just solve it my normal way so I don't get
Solve it your
confused?
normal way, right?
Alright, is it okay if I don't show any, like, if I, don't show any work, but if I just go from there to there?
Oh
That's
my,
okay, right?
I don't know. We'll talk about it in a little bit. All right.
You'll be okay.
Whoops.
All right, now this is this the last page or the first page of yours?
No, that's,
This is number 1. So it
first.
says number 1, so it must be the first one. I really like doing some of your homework with you.
I like
Would
it
you-
too. It's the very first page.
Would you like it if I keep doing homework with you?
Yes,
Like
yes,
these as examples
yes.
instead of putting,
Yes.
then it means less work for you at home,
Yes.
right? And you have them there in front of you, and but
That's
that
the
means
whole
less
point,
notes that you're
isn't it?
taking. Is that okay, right?
Well, technically you are taking the same amount of notes. It's just not on note paper.
Right, it's not on those little note sheets. Okay. All right. If that ever gets to be something where you want me to give you more examples not in your homework, if you can't say it to me like right now because you don't like that, you want to send me a little message, I need more notes or something else, please tell me. I need to know. All right. So I want to know which lines are parallel, and I want you to tell me why.
Goodness gracious.
Okay. All right. So right now I've got
QAnon.
5 lines up there, and I messed up a little, so we have a number 23 in the middle somewhere. Wait, no.
What?
Oh, wait, my bad. I think
23 is on
6
the
and
end.
6 are the
you
same.
have a 24 there.
6,
Okay, here we go.
why are
So
there-
mine, yeah, because I messed up. And so here we go. This is really for you guys. It's a
24.
24. Okay.
Wyatt?
I just put 2 6s there once and had
It
to
says
fix it.
24 on mine.
Yes,
Yeah,
it does.
does
Good.
on mine
Good.
too. It does
Good.
on mine too.
Good. All right. So if 4 and 10 are 90 degrees, which lines are parallel? Okay. So let's look at 4. I have to mark it. 4 and 10 are 90 degrees. They equal 90 degrees when you add them together.
Complementary. That doesn't tell us nothing. To tell us
So
it's
none of them?
complementary.
Wait.
Was that supposed to say 180?
I think that's supposed to say 180. We're going to say that it's supposed to say. Mark that. I think that's. Oh, and. Well, they're each 90. So that one's 90 and that one's 90. So that doesn't add up to 90.
Oh, they're each
4
90.
and 10 are both equal 90 degrees.
Oh,
Okay, so there we
okay,
go.
okay.
Okay. I was
So that
getting
means they're
worried.
going to equal 180, so it's going to be supplementary. And they're alternate, or same side interior.
You could look at it that way. So which
Right.
ones are parallel? And what's the transversal?
Yeah, they're line S and P.
S and P. Oh, that's all
Oh, we're supposed to do the tiny. Okay.
right.
I couldn't figure out what we're gonna do.
This is what I have to do. I see these reds touch lines. So this red one is touching those 2 lines, and the other ones. You see how I did that? This red is touching Q and S. This red was touching P and Q. Now, if I said you get P, and so we're going to say which ones are parallel?
S and P.
S is parallel to P.
Oh.
You have a new theorem today, or new postulate today, that says something about.
Converse of the same side interior?
Oh, I shouldn't say today. I mean of this lesson. The last 2 we just learned. The last 2 we just learned, those 15 and 16. I don't know what number they were.
Yeah, that's
If
right.
2 lines are
15
parallel
and
to the
16.
same
One of them, if they're parallel to the same one, that wouldn't be true.
If-
If
two-
in a plane, if 2 lines are perpendicular to the same line, then they're parallel to each other.
That's the one I would like you to put down.
Like the
please.
whole thing? Or
Let's see, I'm going to come over. No, just like half of it, Amy. 2
Like,
words. In a plane.
Oh,
In a plane.
Get out of my way.
If you want to,
What am I writing on this? So.
in a plane,
Oh.
if two lines are perpendicular to the same line, remember you have a symbol for perpendicular. And then you can just put then parallel. Does that help? You don't have to say then the lines are parallel. Or even for then, I might even do this. Then parallel. In a plane, if two lines perpendicular to the same line, then all right. See if I can squish that down, but
Couldn't we just put number 16 and postulate?
don't you wish? Because the trouble with that would be is then 16 on what?
On Unit 3 postulates.
And then when you get into college, you will not have Unit 3, number 16. It'll be some other number, and you'll try to remember. I don't remember what number 16 even said. All right. I'm going to erase at the top up here, except for my 24.
I think you were.
What?
I did. Okay. Now, this line is not true anymore. We're going to here. S is parallel to P, and P is parallel to T. What is parallel?
S and T.
I'm still on the other
S and
one.
T.
Give me a second.
Okay.
S and P and P and T. Which lines?
Heidi, you said S and T. I heard you say that, correct?
Yes.
Do you remember the reason for that?
Two lines are parallel to the same line, and they're parallel to each other.
Very good. I totally agree with that. And Mariah, this is the one you wanted to name the transitive parallel postulate or something. Theorem. Yeah. So, and the way I even, if you notice that there's a P in both of them. So it's if you look at that, there's a P in both of them. So it's almost like that those P's kind of like cancel. And S, they don't really, but that's like they do. S parallel to T.
Oh, it's the wrong one.
If two lines are parallel to the same line, parallel to same line, then they're parallel to each other. Okay. These are the only two that we have a then parallel at the end, and it's not a converse.
Wait, what? Sorry.
She said these are the only
I'm
two.
still right.
It's okay. I'll wait, Amy. I'm
Yeah.
sorry.
That's one right faster.
Last thing, 6 and 22. 6 over here and 22 over there. So, are those corresponding? Same side interior, alternate interior, alternate exterior? Corresponding. They're both
Yeah.
on the bottom
Sorry.
left side, but what lines are parallel? Raise your hand if you know which lines are parallel. I just want to know who I'm talking to. Which lines are parallel? I got one person, two people who know.
I'm sorry.
I think I know. Does that count?
Yes, that's all I need. I just need to think I know.
S and
Go ahead, Ryan.
I'm
We're right here, 6 and 22. I have marked that 6 is parallel to 22. I'm sorry,
what?
congruent. 6 is congruent to 22. That's correct. I've stated that. And now we're wondering what lines are parallel. Amy thinks she knows. Yes, you may. Here.
Thank you.
You're welcome. So so are those, we asked the question, are those corresponding? Alternate interior, alternate exterior, and all those other ones. Somebody said corresponding. They're both bottom, they're both left. But corresponding on what two lines? And it had some, now
yeah,
if you know, how many people now do know what they're parallel? Amy, what are parallel? S and T. What makes the transversal then? R, right, okay? So the way I do that is I say, look, this red mark is touching S and R. So I actually draw lines on S and R. And then I say, hey, that red line is touching T and R. So I already have a red one on R, so I can make it on T. And now you can see that S and T are the parallels, and R is the transversal.
I lost my page.
Okay, so then we can come over here and write
The first page
S.
is 3, 5.
and T.
Okay. Oh, I already had that written.
We said it was corresponding, but now we have to decide, do I write the word converse or not?
Converse, because you're proving parallel.
We're proving that they are parallel. So the converse of corresponding angles postulate. This is what you're going to be doing for the rest of those. I did the first 3, and there are about 6 left on that page. We now just added more lines and more things. This is the last of the assignments right before the quiz, and so if this one was difficult, I think once you practice the first 2, they'll get a little easier, okay? All right. We added 2 new theorems. This was the last one. We learned how to find the information when you have 2 or more parallel lines, and you will continue to have proofs, and they're all going to have plans except for one. The proof on your quiz will have no plan.
What?
All right.